Good morning, students. Today we are going to discuss about module number 1, that is Introduction to Power System Protection. Here we are going to discuss about that another topic called as Essential Qualities of Protection. So let us discuss about that essential qualities of protection. As to make one protective scheme or one protective device, the following are the basic requirements being as a one protective device or being as a one protective system. The following basic requirements are required. They are selectivity or discrimination, reliability, sensitivity, stability, fast of operation. So being one protective system or being one a protective device, that device required the following requirements to fulfill as a protective device. Let us see about each and every basic requirement being as a one protective device. So let us going to discuss about the first one, which is called as selectivity. What is meant by selectivity? Why selectivity is required to being as a protective device? So selectivity is nothing but the quality of protective relay by which it is able to select or discriminate between a fault in the protected section and the abnormal condition. So being as a one protective relay or protective system or one protective device, a selectivity is nothing but the quality at which it is able to discriminate between a fault in the protected section and the normal condition. That means the protective device has to identify the normal operation and the abnormal operation, or the normal condition or the abnormal condition. It should be able to distinguish whether the fault lies within its zone of protection or outside of the zone, because a protective relay may give the command signal to the circuit breaker as to trip the circuit breaker. If a fault lies within its protective zone, then only it has to operate. Outside of the zone, it has, whenever a fault happen outside of its protective zone, it does not to operate. That kind of quality is required to being as a one protective relay as to perform the specific task at here. So when a fault occurs on a power system, only the faulty part of the system should be isolated. No healthy part of the system should be deprived or disconnected from the electric supply, otherwise it should be left intact. The relay should be able to discriminate between a fault and transient conditions, especially the transient conditions like power surges or high inrush of a transformer's magnetizing current, because the transformer's magnetizing current is a large current when it is compared with a fault current. It may be 5 to 7 times to its full load current. So when generators of two interconnected power plants may lose synchronism because this kind of transient currents are power surges, because due to these transient currents or power surges, a heavy current will flow through the equipment and the line, which may cause to get a damage. So the power system relay has the following sensitivity to address or to sense the magnetizing current or transient current or power surges and the fault event, whether it is lies in the protective zone or out of the zone. While it is sending the command signal, it has to isolate only faulty element. It is not to isolate that healthy element. This kind of intelligence is required being as a one protective relay. This condition is like a short circuit condition, that is nothing but a magnetizing current whose current should be greater than 5 to 7 times, because if that current will flow, if that current will flow, then it may cause to damage, because it is an high current which is flowing through the equipment and it loses that synchronism when two or more generators which are connected together. So the flow of heavy currents is known as a power surge. The protective relay should be able to distinguish between a fault or power surge either by its inherent characteristics or with the help of an auxiliary relay. So that means we have to sense it either the same relay or with help of any auxiliary relay. We have to identify the current, power surges and the liability of the fault where it has been happened, and we have to disconnect that faulty section of the system right from the healthy section of the system. Thus we see that protective relay must be able to discriminate between those conditions for which instantaneous tripping is required, for which no operation or a time delay operation is required, because sometimes auxiliary relay has to perform the specific task, so that's why a time delay operation is also required. Next one is called as reliability. So reliability is required for every device because it has to operate for long life. So a protective system or a protective device must operate reliably when a fault occurs in its zone of protection, because the failure of protective system may be due to the failure of any one of more elements of the protective system. It may cause to damage its important elements. Generally a protective system important elements are protective relay, circuit breaker, voltage transformer, current transformer, wiring, battery and etc. These are the important elements of a protective system. If any one of the fault happen to any one of the device of this protective system, the total system reliability may get reduces. So to achieve a high degree of reliability, greater attention should be given to the design, installation, maintenance and testing of various elements of the protective system. So then only we can increase that reliability. Next one is robustness and simplicity of the relaying equipment must also contribute to the reliability. So it has to work out very simple manner. There should be robustness, then only we can increase that reliability of the system or protective system. The contact pressure, the contact material of the relay and the prevention of contact contamination are also very important from the reliability point of the view. So especially the contacts of the circuit breaker, it has that high resistance and it can withstand for high temperature, then only we can provide that high reliability up to that 95%, otherwise the device may get damaged, it loses its reliability. The next requirement is called as sensitivity. So a protective relay should operate when the magnitude of the current exceeds the preset value. Preset value is nothing but our predefined value. Whenever the current flowing through that conductor, if it exceeds that rated value, hence the current is called as pickup current. So the relay should not operate when the current is below its pickup value or pickup current. The relay has to operate when the current is above its pickup current or above the rated value. So a relay should be sufficiently sensitive to operate when the operating current just exceeds its pickup current or pickup value or rated value or preset value. Next requirement is stability. A protective system should remain stable even when a large current is flowing through its protective zone due to an external fault which does not lies in its zone. It doesn't operate to open the contacts or to give the tripping signal. Therefore, the concerned circuit breaker is supposed to clear the fault where it may get the signal from the appropriate relay which has been working in that particular protective zone. Then only we can increase that stability. So, but the protective system will not wait indefinitely if the protective scheme of the zone in which fault has occurred fails to operate. After a preset delay, the relay will operate to trip the circuit breaker if that particular zone of the protective system which is not at working means. Next one. Another requirement is fast operation. A protective system should be fast enough to isolate the faulty element of the system as quickly as possible to minimize the damage to the equipment and to maintain the system stability. For a modern power system, the stability criterion is very important and it required a proper operating time of the protective system should not exceed the critical clearing time to avoid the loss of synchronism. Otherwise, we lose the synchronism where two or more generators which are commonly operating at one point or otherwise a proper damage may happen. So other points under consideration for quick operation are protection of the equipment from burning due to heavy fault currents, interruption of the supply to consumers, and the fall in system voltage which may result in loss of industrial loads. The operating time of protective relay is usually 1 cycle. Half cycle relays are also available for but distribution systems. The operating time may be more than 1 cycle. Thank you.